Hey class, so we got video number 2 here. What I'm going to do is I'm going to answer a question fully from start to finish when we're talking about basically a projectile launch from ground, and then it's going just to land somewhere where we have a nice parabola from start to finish and answer a few questions. So if you want to kind of look at this question before, I'm just going to try and get some glare out of here. Not that that worked totally, but hopefully it works a little bit. This is question 3 from our practice worksheet number 1. So this is the cannonball question. Basically it says that a cannonball person is fired out a cannonball at 40 degrees with a velocity of 18.3. And then it's asking for 3 things. What's the total time that it's in the air? What's the distance in the x direction? And then what's the velocity final over here? All right, so let's kind of go through this and answer a few things. I've got my answer key over here. All right, so first thing I want to do is figure out time, okay? Again, the way that I like to figure out time, there's some other different ways, and to be fair, in the answer key that I give you the full physics version of just how to figure out with one formula. I can go over that in a little bit, but here's the way that I find most students understand it, and here's the way that I will suggest that you do it as well. Let's find the time at the max. Okay, let's break it into this, like if we're gonna have this, let's break it into here and find the time here, because this is not too hard to find, okay? Again, first thing that we have to do though, before we do that, break our velocity into our Vx and our Vy. So, if I do this, if I go cos of 40 degrees times 18.3, I get a Vx of 14.0 meters per second. That is going to stay constant. My Vy is 11, I think, point something, 11.8 meters per second. Okay, so there's my Vx, my Vy. The nice easy way to find time for me, and the formula that I like using is this one right here, okay? My acceleration equals Vf minus Vi over t. And as long as we're using just our y components, it always works, okay? So here's what we're doing, because we know acceleration. Acceleration is gravity, which means it's negative 9.8. So basically, what we're going to do here is it's going to be set up this way. I want to find time to this point. We're going to go our negative 9.8 equals Vf, which is, Vf, which is 0. It's going to be 0 up there. Okay, our velocity up here is 0 minus 11.8 over time. Okay, switch these. Time equals negative 11.8 over negative 9.8. And so time is 1.2 to the max. Okay, 1.2 seconds to the max. Now the nice thing is, because this is a nice parabola, because like it's hitting the net at the exact same height as where it's being launched, from what you remember from I think 2 weeks ago when we were in the actual lab, is that again, the time that it takes to go up is going to be the exact same time to come down. So for question A, what's my total time? Well, the time to the max here was 1.2 seconds. To get total time, just times it by 2. And so my total time, right, is 2.4 seconds. I don't have to do any more math for that. All right, to get the distance in the x direction, and again, there's a horrible glare there for you guys. That just says dx, okay? Distance in the x direction. Yeah, I'll put it over here for you. Okay, b, dx. That help at all? Not really. It's still in that same place. That's annoying. All right, you got to believe me. It says distance in the x direction. All right. This isn't too bad now. Again, we know that our velocity in the x direction, I'm getting out of the screen, the velocity in the x direction is constant. This 14.0 is constant. And so now that I have my total time, this becomes kind of easy. All I have to do is just take that 14 and times it by my time. So to get, this was for question A. For B, all right, all I have to do is just go, distance equals time multiplied by velocity. So my time is 2.4. My velocity is 14. And so I get an answer of, where's my answer? 33.6. 33.6 meters. Okay, and so that's B. All right, let's go over C. Now, there is a very mathematical way, which I'm going to do, I shouldn't say mathematical way. There's a very physics laid out way, which I'm going to do right now to just prove my point. But there's also just a very nice symmetry way, okay? So I'm going to erase this now, A and B. For C, it's asking for the final velocity, okay? please remember, when we do velocity, especially when we're talking about projectiles, I need an angle. This thing is going to be coming down at an angle at this exact time. Okay? And that angle is going to be changing. If you think about it right here, the angle is basically, it's only moving the x direction. There's no y, which means it's moving just straight east, we'll call it. Okay? As it's going faster and faster, as that Vy gets bigger, that angle is going to get going more down. And eventually it's almost going to be straight y. It's always going to have that x direction, but it's going to keep having more and more of a velocity in the y direction, which means this angle is consistently changing, okay? But let's just talk about the symmetry way before I do the crazy kind of physics way. Not crazy, it's not crazy. It's just more work. If I leave at 18.3 meters per second at 40 degrees, it goes up and it comes back to the exact same height, which is this question. It says that like it hits the net the exact same height as it leaves at. If that happens, all you have to do is just say it's going to hit here, this net. Let's say this is the net. It's going to hit this net, my beautiful drawing of a net, at the exact same velocity. Okay, it's going to hit it at 18.3 meters per second at 40 degrees. Now it's negative because it's moving down. It's a negative velocity. And it's still hitting at 40 degrees. It's not exactly the same 40 degrees. This was moving at, let's say, northeast. And so now it'll be moving at southeast. But still 40 degrees. And actually, let's prove this. Okay? Now, my Vx is not going to change. It's 14 the whole way. But I do kind of figure out my Vy right here, like my actual velocity in the y direction here. Okay? Now to do that, I probably need to figure out like what was my height here. Okay, and that's probably what I need to get, because if I can get my height here, then I can know like what my Vy is in this. So let's actually figure out how high this max thing got. Alright, so let's do that. The nice thing is this is not too bad. I can do this one right here, my distance. Okay, because I have that time, remember I had a time of like 1.2 to the middle. We'll do that right here. My time in the middle is 1.2 seconds. If I go, what's the distance just in the y direction? Okay, distance in the y direction equals, well, what was my velocity initial here? I had 11.8. 11.8. What was my final velocity here? Well, 0. Okay, divided by 2, multiplied by time, 1.2. So when I do this, okay, when I go 11.8 divided by 2 and then times by 1.2, I get 7.1. 7.1 meters. So it had a distance up here of 7.1 meters. Okay, that is how high I got. All right, now I can use that distance, okay, and I can actually put it into this here, okay, to figure out what's my final velocity. If I know that my Vy is 0 up here, I now know how far it's dropping, okay, because I just figured out this dropping. Okay, I can figure out what that velocity final is going to be. Okay, so let's kind of break this into the next part. Velocity final squared equals like 0 squared, that's my Vy. My Vy up here is 0. And I want to stop here. You could use like 2 or 3 different formulas here to figure out this final velocity. You could for sure use this one here, because you know the distance it's dropping from, you know the time, okay, you know that the Vy is 0, you could do that one there. You could basically do this one, okay, you know that the Vi up here is 0, you're trying to figure out the Vf, you know the time, it's going to drop for 1.2 seconds because that's how much time is in the back half. You know the acceleration. So you don't have to use just this formula. The nice and kind of sometimes confusing thing about projectiles is that formulas can be like, you can use different formulas to get the same exact answer, and you should get the exact same answer. All right, I'm just using this one just because I kind of like using this one for this kind of type of question, the Vi and the Vs. So you get 0 squared and then plus 2. I know that my acceleration is helping here, 9.8. I now know how far it's dropping, 7.1. Okay, so this just goes away. 2 times 9.8 times 7.1 gives me 130. Oh, I had it. Oh, let's use the calculator. 2 times 9.8 times 7.1 gives me 139.2. 139.2. Okay, Vf squared, so square root. What is my velocity final? Well, when I square root that, I get 11.8. Okay, Okay? Isn't that amazing? My Vy is exactly the same here as it is there. Okay? And now, if you wanted to exactly find that negative 18.3, you would go 11.8 squared plus 14 squared, and then find the square root. Do you know what you get? You get 18.3. Okay? Now, when would you have to do this work? Okay? And the answer is, if you're ever on like on the next question I'm going to do, if you're ever on an elevated hill, so let's say you're already 40 meters up, and you hit the ground where like below, obviously, from where you shot a cannon, in that instance, your velocity final is not going to be the same as this because it's not a perfect parabola. So that's when you have to do all this work, okay, to find the actual new Vy. Again, your Vx is always going to be the same, but you've dropped farther down a hill, which means your Vy will be bigger, okay, and that's when you have to do this work. But in this question, if you ever get a nice perfect parabola, which means it is landed wherever exactly shot, your initial velocity will be exactly the same, now granted in a different direction, but exactly the same from the start to finish. Okay? So there's kind of a few different looks at projectiles and things from the ground, okay? We can always break off the time and the distance at the halfway point. Total time is not too bad to find. The distance in our x direction is not usually too bad to find, and then our velocity is pretty easy to kind of look at. So those are a bunch of things to kind of look at from just this type of question. Hopefully this makes sense. If not, come talk to me. All right. And yeah, next question, we'll have a question like this, but off the hill. All right, thanks, good. Sounds good.